Good afternoon, everyone. I am Dominus Orbis, and today I will be doing Packet Tracer 4.2.2.6, Configuring Frame Relay Point-to-Point Subinterfaces. Now, the main reason we're going to configure a subinterface on a point-to-point connection using Frame Relay is because distance vector routing protocols such as EIGRP cannot forward routing updates due to split horizon. And if we remember, a split horizon is basically when a routing update is sent to a port, that same update cannot exit the same port that it was received on. So the subinterface is going to allow us to kind of circumvent that. And then also, link state routing protocols such as OSPF are unable to complete neighbor discovery. So let's go ahead and look at the topology here. And the instructions, it says here, we'll configure frame relay with 2 subinterfaces on each router to reach the other 2 routers. Also going to configure EIGRP. So we're going to do R1, start off, frame relay encapsulation. Alright, let's get started. Remember, the default encapsulation on a serial link and Cisco router is HDLC. I'm on router 2 now. Let's be sure and look at the interfaces here. They're all 000 serial. And now router 3. Okay, says we should test connectivity. It wants us to check the pings, but they're going to fail because we don't have a routing protocol set up. That's okay, we can go ahead and open up these command prompts because we're going to need them anyways. It wants us to ping the web server, I think. To the laptop. Okay. Unreachable. All right. Good. Each router requires 2 subinterfaces to reach other routers, that is, in the Delta, the data link connection identifiers. There's a layer 2 address. It's just like a MAC address whenever you're talking about WAN connections are already provided. So here's the command. We're going to go back to R1 and we're going to create a subinterface. Now you have 2 options, point-to-point or point-to-multipoint. We're going to do point-to-point here. And then we actually need to assign it a delc using the interface delc command. Remember, our range is from 16 to 1007, which will be assigned by the ISP. And we're going to do from router 1 to router 2, 102. And then another subinterface, just up arrow. It will also be point-to-point. And that IP address is 110.1.3.2. and then assign the delc as 103. Now let's move on to B here. We're going to go ahead and configure EIGRP, Autonomous System 1, and broadcast both of the networks on the subinterfaces. Notice the packet tracer is not asking us to configure the LAN interface of 192.168.10.0. However, we should configure that in a real-life setting. Let's go ahead and make the passive interface gigabit 00. Let's see what happens if I add that interface, or that network, that is. Okay, good. Remember the command show IP protocols. Our protocol for routing is EIGRP. The K values are default. Autonomous System 1. Automatic summarization is disabled. Here are my networks that I'm routing for, that I'm advertising in my passive interface, and the administrative distance, which is the reliability of the link. Okay. Moving on to R2. And I need to look at my addressing chart up here for R2. Okay, I got an error message here because I forgot this keyword point to point. There we go. Don't forget to add the IP. And then assign it its delc. From R2 to R1 will be 201. And from R2 to R3 is a 203. Okay. I didn't bring up the serial 00 interface. There we go. Okay, now we need to broadcast these networks, advertise them in the EIGRP routing protocol. Got my neighbor JCC with router 1 there. Go ahead and going to add the LAN as well. and then my passive interface, the LAN, gigabit 00. And you would also want to do no auto summary. Okay. Do show IP protocols. Check out EIGRP. Alright, and then here's one. Do show, I think it's frame relay. PVC. Let's see that. Map. Alright, good. Point to point, DLC 201 broadcast status defined active. Alright, looks good. Moving on to R3 here. Okay. Minimize this. Same thing. I also need to bring up the 0000 interface here. There we go. Let's look at the addressing scheme up here. For R3. Alright. The DLC from R3 to R1 should be 301, and from R3 to R2, 302. And indeed it is. Okay. We're not going to advertise the public IP, the one going out to the internet, because I'm sure that's going to have a default route. Let's check. Nope. Looks like I already have 100%. But we want to make that interface to the internet passive. Disable auto summary. Also, we would want to create a default route in reality. Going out the interface facing the internet. I think it's the S010. Yeah, right here. And redistribute that. We can verify that in IP protocols. Redistributing EIGRP, the static. Okay, good. It already had a route in there. A default route. The packet tracer setup. That's fine. And they did broadcast that network. Let's see if I can ping now. There we go. Looks good. What about the web server? There we go. Everything looks good. Alright, let's look at some show commands. We're back on R1. Let's look at the frame relay map. On my subinterfaces 2 and 3, I got a DELC, locally significant 102 and 103. And then the permanent virtual circuit, which is what frame relay uses, will tell us more information about the DELC. It's local, it's active, the interface is here. Packets, the forward explicit congestion notification, which notifies routers if there's delay, and then the backward explicit congestion notification, same thing, and then the discard eligible bit. If you're bursting, all of the frames will be marked that one bit for the discard eligible, telling the frame relay switch that if it doesn't have enough bandwidth, then that packet can be dropped. Okay? And then the LMI is the local management interface. And that's going to tell us what kind of LMI type there is. Remember, we have ANSI, Cisco, and Q9338. It tells us here that we're using Cisco. So it should be LMI 1023. Here it is. The DELC 1023. That's the Cisco LMI type. Okay. Well, once again, I'm Dominus Orbis, and I hope this video has been informative, and I want to thank you for viewing.